Okay, guys, so when it comes to looking at benefits and costs of reducing a pollutant, the thing that you have to keep in mind is on this horizontal axis, whether we have a cleaner environment to the left or a cleaner environment to the right. Different textbooks, different people do it differently. So here we're talking about gunk, and gunk being something bad. So the less parts per million, the better. So here we have a situation where it's cleaner, and here we have a situation where it's dirtier. And you could imagine in this scenario here that potentially, if it wasn't for any government action, we would have a level of emissions over here, and that afterwards, any reduction that may happen leads a large benefit at first. This is marginal benefit, and it's not too expensive at the beginning, and then it becomes more and more costly over time. So the big thing that we have to keep in mind is that both of these curves here represents marginal. So the M and the MB and the MC is for marginal benefit or marginal cost. Meaning that here when we're looking at 16 to 15, this area here, this whole area, that represents my marginal benefits of reducing this pollutant from 16 to 15, or in this case here, if we're only reducing it from 16 to 15, that is also my total benefits. But if I were to reduce it even further, while I'm going further to the right, I could see that the benefit, the marginal benefit I get from that reduction is slightly less, because now that the pollutant's not as concentrated, it's not as hurtful for me. So the extra benefit that I get is this area here, but my total benefit of going from 16 to 14 would be this whole area here. So this would represent total benefit. And then for each of those units, I could think of the marginal benefit for that first unit of reduction, second unit, and so on and so forth. Same thing goes if I look at costs. So if I focus on the costs here, well, the costs initially for producing or reducing emissions by 1 unit or 1 part per million is not too costly. If I reduce it a little bit more, it's a little bit more, and so on and so forth. So it's often this case that reducing something a little bit is not that expensive because it's quite easy to do so. There's technologies available that allow you to reduce at a low cost. But the further to the right that you're going, the more complicated it gets. So at first, if you're thinking about reducing greenhouse gas emissions, you could just be changing your light bulbs to use more energy efficient light bulbs. But the further you go along, the more you're looking at like expensive technologies. So marginal benefit, marginal cost, and essentially here we're looking at the margin. So we would want to stop somewhere over here where the extra benefit is equal to the extra cost. We don't want to keep on reducing beyond this point. We don't want to achieve 0 parts per million necessarily, because those extra units going from, let's say, 7 to 6 leads a higher cost, which would be this whole area here, than the benefit, which would be this whole area here. So we stop before that point. So this is why we stop when we intersect. It doesn't mean that we're not getting any benefits, because if I think about the whole benefits of going from 16 to, this is around 7, well, the whole benefits would be this whole area here. Okay. And then my whole cost would be this whole area here. So if I were to look at only this triangle here, this would be my net benefits. So net benefits is just kind of like taking my benefits minus my costs. And here, because we're dealing with the total benefits of reducing that and the total cost of doing that, well, then that would be my total net benefit. Okay. So hopefully that makes it easier for you to understand. You'll have questions in the multiple choice of your quiz that could go about looking at reductions. I'm not sure why they skipped 11 in this example, but that looks at going from, let's say, from 13 to 12. Well, what's the extra cost? Well, the extra cost would be this area here. So the area below the marginal cost curve between 13 and 12, that would be the amount. So always look at what your baseline scenario is. And the extra benefit would be this whole area here from the marginal benefits curve all the way to the bottom. And if I focus on just this middle area here, well, that's the net benefit of reducing emissions by 1 more part per million, because I'm taking my total benefits, removing my costs, and what's left is the net benefit, which is what we're trying to maximize. We're trying to maximize net benefits, so that's why we stop where marginal benefit is equal to marginal cost, and that gives us our big triangle, which maximizes net benefits. Hopefully this helps you understand a different approach at looking at all of this. It's different, obviously, than supply and demand and consumer surplus and producer surplus. The same kind of idea happens, but here we're looking at a marginal benefit curve and a marginal cost curve, so it kind of changes the picture a little bit. So if you have any questions, feel free to reach out. Make sure this is clear before you do your quiz, as you might have a very similar question to answer in your quiz. Take care. Have a good day.